Hello and welcome to Talking Automotive with Mark and John. I'm Mark Pallavestra and my co-host, John Sinclair.
Hi, good morning everybody. Today we're talking on a very interesting topic about technology development, and the company we're talking to is RKLAB AG out of Switzerland.
Introducing the RK Injector, a breakthrough in fuel injection technology, especially for heavy-duty applications.
And what's really fascinating to me is where their technology is and what an impact it can have on the environment. But one of the big factors is not only the technology is great for new engines, but it can also be retrofitted in existing engines. There's something like 380 million diesel engines in existence at the moment. So it's a tremendous opportunity to make a substantial impact on the environment. Mark, what do you think?
I'm a tech boffin as far as this technology is concerned. It's amazing for anyone who is right across emissions, for smog, for greenhouse gas emissions and particulates. This technology hits all of those on the head and improves performance as well. So lots of gains across so many areas of automotive with this technology, and a great episode to listen to.
Yeah, Mark, they're really close to commercialisation now, and they've come a long way over the last couple of years in that. So let's jump in and listen to what they've got to say. Okay, hi Mark. Today we're talking about a very important topic, which is technology development in automotive. And we're talking to a company called RKLAB AG, which is based out of Zurich in Switzerland. And we have with us the MD Gavin Houghton, the Chief Technical Officer and inventor of the RK Injector, Ron Kukler, and the VP of New Product Development, Howard Gerwin from Chicago. Thank you for joining us. It's great to have you on the show, and welcome.
Thank you.
Thank you.
Now, gentlemen, I'm keen to ask I suppose the obvious question is, so RKLAB AG is an engineering technology company. Can you tell us about the business, what you do, where you're located, and what engine producers you work with?
Yeah, sure. I'm probably best to pick up that question. We're based, as John said, in Switzerland, and we chose Switzerland for a number of reasons, but its locality, particularly close to the engine plants of Europe and the technical capabilities that Europe has, and also the ease of access to both Asia and the US, which are our major markets. The RKLAB is predominantly developing quite a revolutionary technology in diesel fuel injection. Ron will give you a little bit of background into the actual technology, but it's actually a self-pressurizing diesel fuel technology capable of delivering fuel into the combustion chamber at pressures unheard of. So we can deliver fuel pressure into the combustion chamber around about 5,000 to 6,000 bar. That's up against the common rail system, which the best in class at the moment is around 2,800 bar. So it's quite a massive step change. And people say, well, that's just an increase in pressure, but what does that do? And what we're finding through all of our test work, modeling, and the empirical evidence that Ron has collected over a number of years is that it has a fundamental impact on combustion, not only for the fuel efficiency, but most importantly in this day and age, for emissions and emission reduction. Predominantly, we're working with two of the major OEMs in the world, one in China and one in Japan. Obviously, engine development is close to the heart of the OEMs, so we're not at liberty to discuss that engine program. But what we have done is we've got a program running with two independent technology consultants, PTL, Powertrain Technology Limited in the UK, and Southwest Research Institute based in San Antonio, Texas. And with those two, we're doing what we call our open programs. So we're developing an injector for a specific engine, but then having that as a showcase that OEMs can look at, academics can view. It's really a demonstration to the world that this technology is not only real and valid, but has a very important role to play going forward.
So right now there's 380 million existing diesel engines in operation globally. So how would you approach those existing engines in their operation?
Well, I think one of the joys of the technology that Ron has developed is its retrofit capabilities. Now, retrofit's not going to be for everyone in the sense of all of the existing engines, but there are a number of very, very large volume engines, particularly in the larger engine categories, let's say the truck engines, and then going into the rail and marine engines, which are very suitable for retrofit applications of our technology.
Yeah, there's the idea of retrofitting improved emissions technology or even more modern engines into an existing platform has been around, obviously, since the early 2000s, especially in California. It's fascinating because oftentimes there's government money that actually will help fund or subsidize the expense of making this retrofit. You can retrofit the fuel injection system. You can retrofit an after-treatment system. You can even take out a 1960s vintage engine from a machine and replace it with a brand new 2020 engine set of engine technologies. And that is, I think, when you look at emissions reduction around the world, that becomes a massively powerful leverage. I mean, one of the things the diesel industry has done to themselves over the years is we have made tremendously durable, reliable, robust product that just lasts and gets rebuilt forever and ever. And so one of the big levers they found in California, which it turns out has the oldest population of diesel engines in the country, in the US, is to take the old ones off the road and replace them with new ones and pay people good money to do it.
So what are the leading technologies currently being worked on, and where do you think they'll fit in the future?
The diesel world has sort of settled on a recipe for emissions compliance, at least up into the large and medium-sized pieces of construction equipment. And that recipe includes specialized variable geometry turbochargers, cooled EGR, exhaust gas recirculation, selective catalytic reduction using diesel emissions fluid or adblue. I think in Australia it's probably called adblue, and diesel particulate filters. And there's been a long journey that's sort of gotten there. And it's sort of the technology space in diesel has become a bit quieter. Now there's the new push is to improve fuel economy, to reduce carbon emissions, reduce carbon dioxide, to improve fuel consumption. And there's another push for another type of particulate emissions, which I'll talk about a little bit later on. The industry went through a long slog that really got them to meet the European standards and to meet on-highway emission standards and to meet off-highway emission standards, culminating in Euro Stage 4 and in US Final Tier 4, which really began taking effect in 2014. So there was a long journey to get there. The industry took a big, deep breath, and now they're looking at, can they improve fuel consumption? Can they improve CO2 emissions? And probably more important, especially today, in today's market with COVID, is reduce costs.
All right, so question I'm going to ask. Diesel has had a stigma, and rightfully so, I think, in my personal opinion. I'm a fan of the technology. I actually drive a diesel vehicle. But there's been the stigma around Dieselgate. What happened, or what do you think was the issue around Dieselgate, and what were the problems they were trying to solve with it?
So in the course of my career, you can tell by the gray hair, I've been around a little bit. I've witnessed actually two waves of Dieselgate. As we say, we think about the one with Volkswagen and everything that uncovered a few years ago, and I'll talk about that in a second. But actually, the first wave of this occurred in the late 90s, early 2000s in the United States, where the diesel engine manufacturers for the Class 8 on-highway trucks actually did something that wasn't a lot different. It was the advent of electronic engine controls, and some very smart people thought, okay, when the engine is not being tested for emissions, we can make changes. Those changes will dramatically improve fuel economy for the user and probably reduce the smoke a little bit. So from one perspective, it looked really good. The problem was it was at the expense of NOx emissions, which is a key constituent in smog, especially in the valley around Los Angeles, which it turns out drives a lot of the worldwide emissions behavior. So this actually has been done before, and they actually had to go into what they call the consent decree, and it cost them billions of dollars, the big engine manufacturers in the U.S. that were involved in this. And it was I think a case in that case it was a race for fuel economy in the Class 8 truck market, because fuel economy was what they were using to sell one engine versus another into the big truck fleets. And nobody wanted to give it up, and they wanted to show the best real-world fuel economy. The engineers were very aggressive in what they did, and they showed a lot of hubris, and they got caught. And it was ugly. So now you fast forward to 2014, I guess, is when Volkswagen finds himself in a slightly different situation. They made some technology assumptions, especially regarding the US market initially, that a certain type of catalyst would work to reduce NOx emissions. What they found was that while that catalyst did very well at the certification point, at 4,000 miles of driving, it did not have the capability to run out to the life of the vehicle. They also found that the alternatives that they had no room in the car to package the alternative, which would have been a DEF solution in the car. So they were boxed in. Initially, they were boxed in and they had no choice but they wanted to make the market. They didn't want to delay the product. And some engineering and business leaders at Volkswagen made a decision to go forward with a solution that passed the tests, but was dramatically non-compliant when you left the test regime. So they spent a lot of time and money in the US and other markets recovering. We personally had a diesel engine in an Audi SUV. We're a rare American family with a diesel. It actually had the exhaust treat system and the controller replaced 3 times as a result of that about all of that work. And they gave us a big pile of money to basically buy our silence. Both Volkswagen, Audi, and Bosch gave us money. And this was something that went across the US, and it really, as bad as the diesel market went other places, it really ended the diesel passenger vehicle market in the US. Brought it almost to an end.
Now, Howard, I'm keen to ask some more questions.
Sure, please.
You've mentioned a couple of topics that I know a lot of people that I speak to in the general industry have a little bit of understanding on, but I don't think there's a really clear understanding across the board, re-diesel, and some of the emission devices or processes that you mentioned. So I'm keen to get a better understanding on AdBlue, the EGR process that you mentioned for diesels, because there's actually some aftermarket accessory organizations here that are really promoting that as a fitment after vehicles are purchased. And also just the mystery around what is a particulate filter and how they work and what are the issues with it.
Sure. Okay, so we'll start with particulate filters where you ended. Imagine a coffee filter, a metal coffee filter that you're making coffee in your house. It traps the coffee grounds, and over time it fills up with coffee grounds, and you have to get rid of the coffee grounds. In a diesel particulate filter in a production vehicle, a combination of high load engine operation, if you're always running on the highway at high load, it will clean itself out. If you're running at light load around the city, every once in a while, it will need to do something to the engine to heat it up, to burn up that particulate matter. But it turns out, as a solution for particulate emissions and smoke, it works perfectly. There is no, if you've got a diesel car with a particulate filter, you don't see any smoke. If you see smoke, something dramatic has gone wrong. It really does eliminate the problem. And as we look to the future, even if we're able to reduce particulates using an advanced injection system like RK's, we may not be able to avoid the particulate filter anyway, because the particulate filter works so well, even down to the kind of particulates that you can't see and are very hard to measure, but are very dangerous for your health when they get into your lungs. So that's particulates. And the particulate filter was really the step that eliminated particulate emissions from as a concern in the world. The problem is it's to manage that system. It's a very expensive system. It requires a lot of engineering to develop a system that runs. I had a diesel BMW for a while. For it to run, that you would never notice that it was doing a regeneration. That's millions and millions of dollars of engineering and hundreds of thousands of miles of testing and lots of people to make that work. It took a long time to get there. SCR, selective catalytic reduction, is a technology that addresses NOx emissions. It addresses NOx emissions by using a catalytic surface and ammonia, which is 30% of the AdBlue solution is ammonia in the form of urea. And when you inject that across the hot catalyst, it reacts very aggressively and basically breaks the NOx into N2, nitrogen, which is prevalent in our atmosphere, and O2. And a little bit of water comes out as a side effect. But again, it's very, very effective. The problem there is it only works when the catalyst is in a specific temperature range. It's a large device, typically in an engine that might be in a truck engine is a 15-liter engine. That SCR catalyst it would be as much as 30 liters of size. So that's a pretty good size chunk to fit even under a big truck. And it consumes AdBlue, depending on how the engine is configured, the decisions that the manufacturer have made, the relative cost of the AdBlue solution in the market versus the price of diesel fuel. You could see it using anywhere from 1 to 10% of the fuel burn would you have to also put in AdBlue to that amount. EGR is really exhaust gas recirculation. It's been around longer than the SCR solutions have been around. It's in most passenger cars today, gasoline and diesel. You are recirculating some portion of the exhaust gas back into the intake to reduce combustion temperatures, also reducing NOx emissions. Typically, manufacturers today, in like what I would call the standard or normal solution for emissions compliance for diesel, use a mix of the SCR with AdBlue and EGR, the two together, kind of balancing the two out to provide a solution that gives good performance and good economy and a reasonable amount of urea consumption or DEF consumption.
If they run out of AdBlue, is performance impeded, or is it just the emissions change?
It depends on the legal regime of the country that you're in, but the expectation is that you receive a number of warnings as the AdBlue tank empties. And once it's empty, at some point it will begin to derate or reduce the power of the engine. And then at some point it will not even allow you to restart the engine. It depends on the decisions the manufacturer made. But in the case of an emission, that strategy actually has to be declared as part of the emissions paperwork submission. So, I mean, you could find yourself out in the middle of nowhere if you have no AdBlue and first of all, you're driving, instead of going 60 or 70 miles an hour, now you're going 30. And if you turn the engine off, it won't turn on again because you've been out too long. To accept the second fluid with the certifying authorities, they had to do that.
So the manufacturer could have a higher performance diesel supplemented by the AdBlue to reduce the nitrous oxides emissions.
Yes.
So that's where an AdBlue engine is better because it'll be performing better, but the AdBlue is then reducing the temperatures or the NOx emissions, so the smog doesn't.
Right. The AdBlue solution works well, and it's been around in power plants and big ships for a long time. It's not a really difficult technology in general to use, but it means you got to have a second tank and you got to keep it full. Now, in a passenger car environment, typically they've tried to size those tanks, and this comes back to the problem Volkswagen had with Dieselgate. They typically size those tanks to be about refill equivalent to an oil change interval. So when you bring your car into the dealership to have the oil change, they refill the AdBlue. When you start to get into a heavy truck, a big pickup truck, a big commercial Class 8, Class 7, Class 8 truck, then you're starting to have to refill AdBlue on the road. And so you typically see an AdBlue tank that's maybe 10% or 20% of the size of the diesel tanks.
Oh, it's fascinating. I think there's a lot of people here don't have a really deep understanding of AdBlue. They just know it's there, but don't understand what it's actually doing and what it enables the manufacturer to achieve from a performance perspective.
Yes.
Now, we've seen a big drive in electric vehicles. We've seen Tesla raise large amounts of capital. What's your view on electric vehicles, and what are the challenges in the market for electric vehicles?
I get asked that question a lot because we're seen to be developing a new technology for what some people consider a legacy asset or a legacy set of technologies. Well, what I would look at is from a fundamental perspective, and both Ron and Howard will elaborate on this, but from a very specific viewpoint, you look at energy density, utilization of that energy, and emissions. And if you look at the world through that very simple paradigm, you look that electric vehicles will definitely have their place, but they will not be dominating the place. They will not be dominating the landscape, particularly in heavy-duty applications, but also across the spectrum. And not only from the point of view of consumers want to have a choice in the engines that they have, but also the economic fundamentals of that paradigm. For example, electric vehicles and the lithium-ion battery has 1/100th of the energy density of diesel fuel, for example. So what we'll be trying to understand in how we evaluate electronic vehicle technology, and particularly the lithium-ion battery, which seems to be the dominant one, is how does it compete against the internal combustion engine on those three fronts? And from our analysis, and particularly from the way that we see the market heading, there's not only room for both, but there's also room for us to be working a lot more closely with them. For example, to have the internal combustion engine, let's say a diesel engine, running as a generator. Not so much in the old concept of a range extender, but having the diesel engine as the heart of the generating capacity. So you can run your diesel engine as a generator, running it at an optimal load and an optimal speed for energy efficiency and emissions, and then feeding the battery power pack. We can also see the instance where that mobile power pack, in terms of a diesel generator, can also be seen as a mobile generator anywhere, powering the house, powering outdoor applications. So we can really see that the thermal efficiency and emissions of the diesel engine of the future and the electric vehicle can work hand in hand. And then particularly when we look at the concept of hybrids, and I know that we'll be discussing hybrids in much more detail, but there's certainly a lot more room for us to be able to optimize the technologies and make that probably the dominant technology going forward.
That's interesting because we had Christoph de Perner from the Asia Pacific region for some of the OEMs that he's worked with, gave us some information around basically the European auto brands aren't investing in diesel anymore. They're going down this path of EV or EV with low capacity petrol engines. Where do you see the diesel product that you've got and diesel engines fit? Is it the right strategy, or is there a in-between where diesel can get back to being a bigger part than where some of these auto companies are heading?
It's funny you say that, because we see the opposite when we discuss with the OEMs. Even the ones that have actually publicly stated that they're going down an EV route, they're hedging their bets. They're not going down one stream whatsoever. And I think when you're talking about the concept of how does diesel then compete with a petrol internal combustion engine, look, we're quite agnostic to which one we choose. Our injector can certainly work with both types of fuel and quite a wide variety of fuels. And Ron will be able to explain that in more detail. You can't get away from this concept of energy density. And the internal combustion engine is extremely efficient and getting a heck of a lot more efficient with our injectors. And what we're seeing then is that it's very difficult for other technologies to compete when you're running at thermal efficiencies of around about 54%. It's very difficult to compete with diesel when you have solved the emissions problems, particularly around particulates and NOx.
Now, we often see it with this whole perception of electric vehicles, and it's often related to the smaller engine. But what's your perspective for the large engines, such as marine, standby generators, construction equipment, rail? Where does the technology play a part for those type of engines?
I think when you get into the higher engine classes, it becomes more and more difficult for EVs to compete against the traditional internal combustion engine on a range of fronts, but particularly around the weight of the batteries that's required, the reliability of those batteries, and also when you're talking about some of those applications, the fire risk, the overheating, the significant practical issues that you see on the ground. So we see that for definitely the foreseeable future, the internal combustion engine will be dominant, particularly with our technology, competitive right across the heavy-duty engine spectrum.
So what is the state of diesel technology development now? Where are we sitting at in terms of diesel technology development?
Well, if I go back to what I said earlier, there was a long, hard road, let's say from like 1998 to like 2016, that brought us to sort of a common set of solutions that you see across Europe, the United States, and Japan for certain. And I'm sure I don't know exactly what's in Australia, but I'm guessing it's similar. And that's this technology package of a variable geometry turbocharger, a cooled EGR system, high pressure common rail fuel injection, an SCR catalyst for NOx cleanup, and a particulate filter for particulate matter. And so now the companies are all sort of engaged in a race around really, I'd say, three things. One is to reduce the cost and improve the quality, reliability of those systems. And when those systems came out, they looked an awful lot like a child science fair experiment trapped to the side of the engine. I mean, it's no joke. This stuff was like, it looked like a chemical factory had been bolted on the back of the engine. And now they're trying to figure out how do they integrate it better? How do they reduce the fuel economy penalty, improve fuel consumption for the customers, and reduce the cost to improve the business model? Because these systems are expensive. They're full of precious metals. They're full of control systems. If you're in the United States, the SCR system has to be heated so it doesn't freeze up solid in the winter in the northern US. There's all kinds of stuff, and there's a lot of opportunity because they really threw a lot of technology at it to meet very strict emission standards and get the job done. And now they're trying to back off the cost. Also, you'll see this fuel economy challenge, especially in the world in applications that have a lot of transient operations. So, like imagine a city bus or a wheel loader loading a pile of gravel into a truck, or an excavator digging a hole. A lot of transient up and down speed, up and down load. They're starting to look at how can they reduce fuel consumption by adding electrification to the diesel engine. As Gavin was saying earlier, we have electric solutions make sense in some ways, and the combination of electricity and diesel makes a lot of sense in some applications, especially where you have a lot of stops and starts, a lot of ability to recover energy during braking, during the cycle. So putting those two together is a big piece of it. The other thing that's out there a little bit is we talked about fuel economy and we talked about electrification. There's also some interest there's always been and there continues to be interest in low carbon fuel. So ethanol fuels, for example, alcohol-based fuels, hydrogen fuels, but trying to still take advantage of the inherent robustness and design of the diesel engine. Actually, the other day I had coffee with a friend of mine who's got a startup working on an ethanol technology and could be a good candidate for our technology as part of theirs at some point. But those are the things that I see as the mainstreams: cost, fuel consumption and CO2 reduction, and low carbon fuels. I would add one more, which is we talked about the particulate filter and we talked about particulate emissions. One of the things that's coming, especially in Europe, is the work that's been done so far on particulates has been aimed at the mass of particulates, the total amount of weight you collect, reducing the total amount of weight of particulates that come out of the filter. The European regulators have become much more interested lately, especially as a result of the gasoline direct injected engines, in the very small particulates. They don't produce a lot of mass. They're sometimes referred to as PM 2.5. You don't see them, but when you breathe them, they get into your lungs. They can cause pulmonary issues. So there's this area about reducing the PM 2.5 emissions. Once you've got a diesel particulate filter or a particulate filter on a vehicle, that pretty much eliminates the problem, but it also limits how far you can go in reducing the amount of particulate filter you use. There's even a Porsche gasoline engine that has particulate filters now on it in Europe because of that.
Now, Ron, can you tell us specifically about the RK injector and how the technology works?
Yes, Mark. Essentially, instead of going down the old path, when the pollution people developed our new problems, we had to have a new type of solution, a different type of mentality. And instead of going down the old path that Howard was talking about, it's a well-trodden path, and we had to change it. And the way to change it is to have totally new technology. Now, so what I've done is the pollution, NOx and particulates, are two separate problems, two separate technical requirements. One is dependent on combustion efficiency. The other one is to do with temperature. So how do you separate these two? The add-ons don't separate the two. So what I've done is, and I've had years of combustion experience in a whole range of things, not just diesel engines. What I've done is the NOx is basically temperature. So you've got a low temperature combustion below the line where NOx is developed. The particulates are an inefficient combustion process. So you've got to make that more efficient. Now, the SAE stated decades ago, if you have an injection pressure above about 45,000 PSI, the particulates almost disappear. Our system runs at about 80,000. I'm talking PSI instead of, the metric standards. You've got to handle the fuel differently to make it behave differently. So by having a high injection pressure, and you actually reduce the particle size dramatically. Now, the surface area of a smaller particle has more availability for oxygen, so you can mix it better. So therefore, if you have a very, very small particle, submicron stuff, instead of plus micron, you get very, very small particles. You can mix the air with it better, but it's never 100% efficient. There's still a downside on it. It gives us also, by having an aqueous chamber, instead of mixing it around like mad with swirl, with the particles bumping into each other and getting bigger and bigger, we have an aqueous chamber where each droplet is basically sitting there waiting for the oxygen. The idea of adding diesel engines are excess oxygen machines anyway, but the idea of adding 3 or 4 times as much oxygen, if it's not mixing, it's still doing nothing. So therefore, aqueous chamber lowers the temperature and also improves the mixing. So the combustion technology we've developed, and I can't go into the specifics of it, is that we clean the chamber in the chamber. We don't clean it once it comes out the exhaust. It costs more than what the engine's worth, and it's no good for the engine life. So by cleaning the engine inside the cylinder, you don't have all the other stuff hanging on the end. It's undesirable to have all the stuff hanging on the end. Lots of good people do lots of good work. They should be looking at the beginning of it, not near the end of it. So by having the particles we have developed what I call blue flame technology. If you look at a diesel engine under combustion conditions, either through a sight glass or a crystal glass or for any of the computer programs, you'll see it's basically full of yellow flame. And the yellow flame is carbon particles igniting, being set alight, and they're giving off the particulates. That's all particulates in that chamber. If you get a chamber which has no yellow, you've got no particulates. So all you do is get rid of the yellow flame. You get rid of the particulates. The yellow flame is also radiant heat. It's the fastest form of heat transmission you can get. The slowest form is convection. Now, convection comes from blue flame. There's your answers. And that's what we do. We have blue flame technology. The ideal situation is to have no colour flame technology. Yeah, that's the next step. And maybe we can get to that. So it's a situation of working in a different direction, with a different technology for a new solution. And that's what we're doing. The reason why we don't have a pump is we have the injector as its own pump. There's a number of reasons why that, but one of the reasons is that the piston drives the injection pressure, but the injection pressure and the burning pressure are interrelated. So the pump will work at the rate at which it's being burnt. So you can't burn excess fuel, because the combustion dictates that you can't do that. The engine combustion should actually control the rate of your injection. And this is what we do with our system. It's a totally different system. It's also economical because when you replace a pump is an exceptionally expensive part of a diesel system, very finely engineered, and it's probably one of the most unreliable parts because it's doing a hard job, doing a heavy job, and also they can be noisy, of course, but it's not the right approach. And by doing what we do, by allowing the combustion to control the injection pressure, and we can control all those components anyway, that's the better way of doing it. It's less stress on the engine.
Now, Roger, around diesel as far as the fuel. So I'm fascinated with the technology and the science behind it. So smaller particles, better atomization, and therefore better adherence to the oxygen for better and more efficient combustion, which means less particulates going out into the exhaust, which would mean that your particulate filter would have an easier job or even eliminate it. You wouldn't need AdBlue, you wouldn't need an EGR valve, and you wouldn't need a particulate filter.
EGR valves are about the worst thing you can put on a petrol any motor. They basically put exhaust back into your combustion chamber. You lose power, the wear rate is faster, and it won't work on diesel motors in the long term. It's a fill gap technology.
And also, so with fuel, is there a requirement for a higher grade of diesel, or how does it fit from a low sulfur or different quality of fuel? Is the injector that you've developed friendly to different grades of fuel, or does it really need to have a high standard?
Yeah, it'll work on any liquid fuel, but the sulfur in fuel is a lubricant, and our diesel injection system is a low lubricity device. It has no bearing pressure. It develops oil fuel lubrication with each stroke, and it doesn't need sulfur. The lower the sulfur content in fuel, the better for everybody. There's your smog. Sulfur has to be in fuel at the moment so that the diesel injectors last. But with our system, they can reduce that sulfur dramatically.
I'm an old mechanic, right? So I have vivid memories of when EGRs came in on petrol cars back in the late 70s. And basically the mechanics, I never did this, the mechanics would block up the valve to stop the EGR from working because it basically robbed you of horsepower.
They put a ball bearing in, take them 2 minutes, and they charge you $50.
Correct. So it's fascinating that there's so many more EGRs now creeping into the diesel space. I'm amazed that your injector can actually eliminate all of these hang-ons that basically reduce power and efficiency, but help the environment. And it's important to help the environment because we want to have a cleaner, greener world for us and our descendants. So I think it's fascinating, and the technology sounds It just makes sense. The blue flame, so that is the convection heat, not the radiant heat. Is that correct?
Yeah. Bearing in mind the blue flame still has some pollutants in it, but very minor, and none of the ones we worry about. And diesel itself has something like 85 carcinogenics within the diesel fuel. So when this is solved, there will be other problems.
And this is where the thermal efficiency that Gavin was talking about, how you can get this engine to be so much more efficient, because thermal efficiency was always the nirvana of a diesel versus a petrol, because you're always naturally better from a thermal efficiency. Your radiators ran cooler on a diesel than they did on a petrol, because you're wasting so much heat on a petrol car. So this technology just takes it to another level.
Yeah, thermal efficiency is a strange subject. What we do is we waste less fuel. We're not necessarily that much more thermal. The numbers come out at more thermal efficiency, but actually we waste less fuel. So when you have finer droplets, you get more complete combustion because of it. You need less droplets in the chamber. If you have less droplets being wasted to particulates going out the exhaust pipe, you have finer droplets in the combustion chamber, they burn complete. So you have less droplets, less fuel. That's how we waste less fuel. In the end result, people call that thermal efficiency. I have a different opinion, but that's
Howard,
interesting.
a question for you. I'm keen to get an understanding on how do you get this technology commercialized? Because this is fascinating. This is really groundbreaking stuff for someone like me for the first time hearing it. Very exciting technology. So how do you actually commercialize it?
You can look at it through a couple of lenses. To commercialize the tech, I think the challenge is that you're working with a bunch of engine manufacturers and fuel injection system manufacturers that are very risk averse. They've got, as Ron said, they've invested millions, if not billions of dollars into the solution that we have today. And it's not an elegant solution, certainly, but it works, right? I mean, it's a solution that it's effective. It meets the standards. Customers they don't like it, but they're used to it. So now the challenge is you're going to bring something new to the market that's a lot different than they've seen. It disrupts their whole Apple cart. It knocks over their Apple cart. It disrupts their life. And now they have to figure out, how do we use it? It's going to take money. It's going to take time. They've got to figure out how to take the best advantage in each of these engines of this new tech. How do they do that? That's kind of like the barrier. That's the challenge. Is how do you put together such a compelling state that a company suffering from technology development exhaustion in the diesel world, really, it's a fatigue factor. How do you convince them that this is something that they have to do because it's so much better than what they have? And when I started to read about what Ron had developed, and one of the reasons I got involved is I do believe there's a compelling answer. But the compelling answer goes across a lot of dimensions. The fuel economy improvement dimension, the emissions reduction improvement dimension. Maybe for a lot of these manufacturers, it's the total cost of bringing a product to the market dimension. But it's got to look really good in all these directions. Otherwise, it's going to be hard to get somebody's attention.
Howard, are you able to share where you are with the development of the technology and what companies you're working with and what are your sort of next steps?
Well, for me, we are restarting our work with PTL, as Gavin mentioned, and Southwest Research. And the next step is to get it into a representative, get the technology ready to put into a representative engine for representing one of our engine partners, and fine-tune and develop the combustion recipe. This injector, the combustion parameters that Ron's described are a lot different than anything that's out there today. So it's not just as simple as dropping a new injector in and letting it fly. We have to look at what else has to change. And so we need to finalize the injection system design, and the work, it all looks pretty good right now. Finalize the rest of the combustion system. So for a diesel engine, that's the bowl into which the fuel is sprayed, and figure out, Ron mentioned that we don't need a lot of swirl. This injector has the swirl is a way to generate energy in the chamber to mix. This injector does all of that itself. So we need to figure out what is the best way to take advantage of that in the combustion chamber. It turns out that reducing swirl also improves efficiency and reduces heat loss. So there's a lot of good things there, but it's now about developing that recipe. And when the recipe is developed on the computer in the simulation, it's going to go, we're going to build some parts, and it's going to go to the lab and get tested and see if the cake really comes out the way we expect it to.
I spent most of the last couple of decades in the lab. We've done a lot of testing already. For me, it's well proven beyond the fact what we need is someone that has a little bit of blue sky mentality, but a tiny amount. blue sky, as I see it at the moment, is mainly in the commercialisation. There will eventually some numbers will adopt it. They all seem to be quite keen. Those that don't eventually will be left behind. And that's the way disruptive technology works. The last disruptive technology we had was disc brakes. What happened to the drum brake manufacturers?
It's amazing. I think back to, once again, my early days as a technician, and swirl and quench were the holy grail of trying to get a naturally aspirated engine to operate with hemispherical heads and all the other bits and pieces. And it's just interesting to hear that you don't want swirl because your injector is that good that eliminates the need for the air to whiz around in the combustion chamber to get that good flame propagation across the cylinder. So yeah, this is pretty exciting technology. So as far as the next step, it's to get the commercialisation. Is that what you're looking at as far as the operatives you're looking for, but you're looking for a manufacturer to jump on board and put this in, whether it be a marine, truck or automotive? Is that where you're at?
I'm happy to answer that one. We actually have a range of strategic partners at the moment, some of the largest OEMs in the world. And we want to work with the broad spectrum from passenger cars all the way through to heavy marine engines. The next step, as we've said, is to work with our existing strategic partners on engine development, which we have. But secondly, is to bring up a much more broader discussion where people from academia, people from other OEMs, can go to Southwest Research where our engines are being tested and demonstrated, run their own test programs, evaluate the data themselves. Really, we want to open this debate. We want to have a broad discussion on this technology and then its applications. The next step is then commercialization on a much broader front.
We are engineering innovation with our Blue Flame technology for a greener world. Embrace the future and enjoy a cleaner ride.
Gavin, thanks very much. I think this has been a really interesting discussion this morning. Before we jump into our summary, if there are any companies or academics who would like to get involved in the RKLAB research programs and get in contact with one of the team, they can do it through the following contact details. Mark, would you like to do a quick summary?
Oh, I would love to, John. This stuff, this technology is actually pretty cool. And once again, getting back to being an old tech, this stuff, as a kid at school, I used to read about all this technology, and EGR valves were only a fairly new thing at the time. So when you look at from a high level summary, and gentlemen, I'm keen to correct me if I'm wrong in any way here, but we're dealing with a problem where we've got diesel with a stigma. There's been Dieselgate. There's been a whole series of after combustion devices that have been introduced on the journey to fix the problem of particulates, nitrous oxides, which cause smog, and obviously CO2, which we want to reduce greenhouse gas emissions. And diesel's inherently a good fuel for that, but it has those bad side effects. So AdBlue, EGRs, and particulate filters are in play, but this technology that you've introduced is all about increasing the pressure of injection in a diesel engine, and it actually negates the traditional injector pump because the injector's doing the work itself. So there is the opportunity to retrofit, and it's through that higher pressure you have a better fuel flame in the combustion chamber. Now that flame currently is yellow, but with your technology it's blue. Now blue, if you look at the old Bunsen burners at school, when the Bunsen burner was yellow, it means it wasn't really that efficient, it was just burning a lot of gas. Whereas when you got the flame to be blue, it's more efficient. And that's where you've got the radiant heat versus the convection heat. And the convection heat's the strongest stuff, which is the blue flame. So you can actually use less fuel and get more energy out of this high pressure injection system. So you're fixing the NOx problems and the particulate problem in the chamber, not after the chamber. So you're actually providing a solution that can fit not just automobiles, but machinery, trucks, and marine use, because we still know there's going to be a need for a liquid fuel as opposed to just electric cars going forward, because electric cars will not fit in every application. So this technology is super relevant because it actually disrupts what is the traditional diesel engine configuration and actually makes the diesel engine very relevant as a complement to EVs for what they're going to be used for. Countries will need to have diesel technology in other areas. Have I summarised that right?
Yeah, the only thing we haven't really touched on is that it's not just the internal pressures, but we have a specific nozzle, our dispersal nozzle, which creates, again, much better mixing of the air and the fuel in the combustion chamber. That's the only other thing I would probably add.
I'd like to just say thanks very much. I think it's been an informative session and across a quite complex subject. So thanks very much for putting it into simpler words that we could all understand. It's much appreciated. So thanks very much.
Thank you for listening to this podcast. Hopefully you got as much out of it as we did. Amazing technology, and one that definitely will go hand in hand with EVs and the other new forms of automotive propulsion that we're going to see in the short and medium term. If you like this, please like us on YouTube, like us on LinkedIn, and make sure you subscribe. So that way we can update you with new editions that we do publish every week. And also look out for our dispatches that we will be sending out midweek with snippets of future episodes and also some summaries of past episodes.
Yeah, thank you everybody for listening. Keep safe. Speak to you next week.